Yeah, perfect. Okay. So now here in the previous session here, we spoke about the basics of collection, we spoke about the core part of collection, and we understood a lot of implementation classes, right? So in today's session, we are going to talk about a very, very, very important topic for your mock, for your interview, for your project. Everywhere this particular topic will be used here. Okay, so the topic which we are going to use, do it in today's session is how do we compare user defined objects. So I'm going to explain how do we compare user defined objects here. Okay, user defined objects, and then we can sort them. Okay, so this is a very, very important topic. How do we compare user defined objects and sort them based on one particular criteria here. Okay, so now here let me just go back to my Eclipse over here. Okay, so in my Eclipse we have already created a project called as collection framework. Under that we are done with 5 days here. Okay, so in today we are going to talk about something called as package name is default sorting. The package name is default sorting. Okay, so now under the package called as default sorting here, let me create a class here. Okay, let me create a class, and the class name I will write it as car here. Okay, so now here I tell package. Okay, it can be package or public or whatever it is, you know it better, right? So now here it's a very, very simple program which I'm going to create here. Okay, so we have a package called as default sorting. It means we have a folder called as default sorting, and car.java file is present in that folder called as default sorting. Okay, and then here class is a blueprint of an object, and the class name is car here. Okay, and each and every car will have something called as cost. Correct? If you talk about any car here, every car will have some cost price, right? So, and then I am trying to initialize it with the help of a constructor here. So now here I tell int cost, and how am I supposed to initialize it over here? This dot cost, okay, equals to cost here, and we know what are we trying to do as well. Okay, now here just understand over here, when I write it as main method, okay, if I create an object of car, and if I pass the the cost price has 100 over here. Okay, and when I try to print the object reference over here, can you tell me what will be the output? This is a simple program which we are trying to do now, and we have already done these kind of programs here, similar programs. Now tell me what will be the output. See, we have a class, a car, class called as car. It has a variable, and we are initializing that variable with the help of a constructor, and the execution starts from the main method. I created an object of car, and I have initialized the cost here. When I try to print C here, what will be the output? I want answers from you all. Okay, what will be the output here? Sir, whenever I try to print the object reference here, okay, it internally calls the toString method. Whenever I try to print the object reference, it internally calls the toString method. And since I have not overridden the toString method, the default implementation of toString method will get executed. That is fully qualified class name at the rate hexadecimal value. See, that is the string representation. That is the fully qualified class name at the rate hexadecimal value. I am getting the string representation of an object. So if I want it as, okay, if I want the content to be displayed here, it's very simple, sir. You override the toString method. Public is the access specifier, string is the return type, toString is the method name, open parenthesis close, open curly braces close. And this is an overridden method. So I will write it as annotation override. Okay. Now I will tell return cost here. Can you tell me why is it giving an error over here? Why is it giving an error? Why is it giving an error, guys? Apply common sense and tell me, no? Why is it giving an error? Sir, simple, sir. Return cost means you are returning an int type. See, cost means you are returning an int type. But the return type of toString is string here. So it's mismatch over here. If I just hover on it, it's telling mismatch. See, type mismatch cannot convert from int to string here. So how will I convert the integer into a string here? It's simple. I have to just concat one string over here. if you concat a string to anything, it always behave as a string. This is a string, no? Plus this cost will get concatenated. So it will ultimately behave as a string here. So if I do not override the toString method, this was the output I was getting. Correct? The fully qualified class name. But now when I execute it here, did I get the output as cost equals to 100 here? This is the advantage of the entire data here. Okay. So this is all about the entire process. Okay. ToString method is overridden everywhere. Okay. In all wrapper classes and string class as well. Okay. So it's overridden in string class as well. That's the reason. See here. When I tell string s, I've done this already. Okay. I mean, when I did string class, I've already done it. Okay. See here. When I create an object of string here, and when I try to print the object reference s here, see, I created an object of string here. But when I try to print the object reference, it should give me the fully qualified class name at the rate hexadecimal value. But I'm getting Java over here. So it simply means that, okay, whatever value I pass it over here, the value is displayed. So in the string class also, toString method is overridden. Okay, so that way we need to understand. And even in all wrapper classes also, see, integer a z equals to new integer of, and I pass the value as 10 here. Now when I try to print the object reference over here, okay, object reference z over here, look at the output here. I am printing the object reference. I should have got the string representation, but I'm getting the actual content whichever I passed here. So toString method is overridden in all wrapper classes as well as string class here. Okay, so that's the just an understanding of this data. So I'm not trying to do this all. Okay, this is all for your comment section here. I'll just add it at the last here. Okay, this is just for your understanding. Okay, now we just got the basic idea about this entire data here. Okay, so great. Okay, perfect, guys. Okay, so now here, we have to just concentrate on the first half here. Okay, the reason I did this for is to understand the major part. So what did you understand with this program, guys? It's a very, very simple Java program, right? Sir, we have a class called as car. It had a variable called as cost, and I am initializing it with the help of a constructor. And I have overridden the toString method because if I do not override, I used to get the string representation. But if I override here, I will get whatever content I have passed. Okay, whatever content I have passed, right? The same content will be printed over here. Okay, that's it. Now I'll tell one more class. Control N. I will create a class called as sort car here. Okay, the class name is sort car. So now here, package. Okay, I mean it's sufficient package, and I want the main method over here. Okay, and I tell enter here. Perfect. So now here I have a class called as sort car, and that I will just drag it towards the RHS here. I'll just drag it towards the RHS here. So now here in sort car here, I will create three objects of car. Car C1 equals to new car of, and the cost is, imagine it is 200. Okay. Similarly, I can create any number of objects for a specific class. So let me create, three objects here. 300, 100 and three objects. C2, C3. Now I will create an object of tree set. You know what is the specification of tree set, right? Yesterday we did it beautifully, right? So we create an object of tree set, okay? Open parenthesis close, open curly braces close. I mean, see, we created an object of tree set, and I have to import the tree set class from util package. I've imported. So now here, I will add all the car objects into my tree set. C1, T dot add of C2, T dot add of C3. So I am adding car objects into my tree set. But now if I just add one string object also, it will get inserted. See, string object also I can store. I can also store integer object also. See, in my tree set, as I told you, it is always heterogeneous. Collections are always heterogeneous. But now I want to store only car objects into my tree set, not the string object, not the integer object. So I have to make use of generics and tell, hey, tree set, please allow only car objects. So when I make use of generics and tell car, the tree set will allow only car objects. Integer, string, employee, dabba fellow, monkey, no objects will be allowed. Okay. So I'll just close this. Clear? So now here I will traverse it with the help of for each loop. Okay. In my tree set, there are only car objects C1, C2, C3. There are only car objects. So I am going to traverse car objects, car C colon, from which collection? T. So now when I tell sys out C over here, what will be the output here? Can you all tell me the output of this entire program here? You know, the specification of tree set is to sort. Okay, always remember tree set will sort. Now tell me what will be the output. Any random guess here. Okay, random guess. What should be the output? Think over it and tell me here. Okay, think over it and tell me. Any idea what will be the output of this entire program here? Okay, so majority, many of them will tell here, okay, 100, 200, 300 because it's going to sort here. Okay, so now here, let me just explain you this entire program here. This was the answer I expected. Okay, this was the answer I expected, but I generally get an exception called as class cast exception. Okay, and the reason over here is, see, car cannot be cast to comparable. So in simple terms here, okay, I'll just tell you one common part here, okay, which we did yesterday. Okay, see here. Yesterday, did I mention the point here? T dot add of, okay, 10. T dot add of, okay, I'll tell 10.5. T dot add of, okay, remember the point I told yesterday, okay, I'm repeating it all over again today because for your understanding. See, I repeat, concentrate. When we add an object into tree set, when we add an object into tree set, when we add an object into tree set, which method will get called internally? Compare to method will get called internally. Correct, no? Everyone knows, right? When we add an object into tree set here, you like it, you don't like it, compared to method will get called for sure. Okay? And this compared to method will return +1 if it is greater than, -1 if it is lesser than, and 0 it is equal to. We know everything. But now, sir, where is this compared to method present? And when, how does it get called? Sir, if I add 10 over here, it is calling the compare to method present in the integer class. Because I'm adding 10, it's an integer object. If I'm adding an integer object, it will be called the compare to method in the integer class. If I pass 10.5, it's a double object. So when I pass 10.5, it's a double object. It will call compare to method in which class? Double class. Clear? Similarly, if I pass a string object, okay, the string object will internally call the compare to method present in the string class here. So based on the object which I'm passing, okay, so that specific compare to method will get executed here. Similarly, as of now, okay, when I pass car object, see car C1, car C2, they're all car objects. When I add an object into tree set, compare to method will get called. But since I'm adding car objects here, it will go in search of compare to method in the car class. It will go in search of compare to method in the car class. Do we have compare to method in the car class? No. So then based on which criteria will it compare and sort here? So that's the reason here you have to make the car object as comparable in nature. So I told you, right, all the wrapper classes and string class will implement the comparable interface and it has overridden the compare to method. So whenever you add an object into tree set, compare to method will get called. Since now I am adding car objects over here, it will go in search of compare to method in the car class. Do we have compare to method in the car class? No. So then how will it sort here? How will it compare here? We have not at all told, right? So that's the reason you have to make sure the car objects are comparable in nature. So that's the reason you have to make use of comparable interface. Okay. So that's the reason here we have to talk about the topic called as how do we compare user defined objects. Okay. Car is an user defined class and I'm going to compare the car objects. Rule number 1. See here, we are going to talk about comparable. Comparable is a predefined interface present in Lang package and it was introduced from JDK 1.2. So it's an interface. Interface means it will have only abstract methods. Okay. And that is present in java.lang package. So I need not explicitly import the comparable interface because lang package is automatically imported. So comparable is an interface. So it should definitely have abstract methods only. And that abstract method is compare to. and the syntax, and it compared to method returns +1 greater than, -1 lesser than 0 if it's the same object here. Okay, if it's the same content here. So public, the compare to method is an abstract method. In an interface, all the methods are automatically public and abstract. So it's not necessary that I have to mention it as public. Public means it can be accessed by everyone. Int means it's written +1, -1, 0. Compare to is the method name. And when I tell object over here, it can accept any type of objects, meaning it can compare any types of objects. Okay. When I tell EE here, it's specifying the element type. What type of, see, yesterday I showed you, right? Internally, the syntax will be uppercase E and E here. So that would be the syntax. So in simple terms, it means here, we can compare any types of objects here. Okay. So why do we use comparable? To compare and sort the objects here. The major use of comparable is, okay, what is the job of comparable? Comparable is used to compare compare objects and sort them. Compare objects and sort them here. Okay. So this is the job of the entire process. Comparable interface is used to compare objects here and sort them. In simple terms, it is used for default sorting. Okay. It is used for what? Default sorting. Sir, what is the meaning of everything, sir? I will tell you in a beautiful way, guys. Okay. You have to just understand the basic flow here. Okay. Now, so now here, understand, this is the point we're going to learn now. Okay. What are the rules, okay, to make use of comparable interface? Rule number 1. Okay. The class has to implement the comparable interface. Okay. Second rule, specify the generics type of which objects we are going to compare. Okay. Let us try to do it. Now in my specific program here, okay, the class has to implement the comparable interface. So I'll tell implements comparable. Okay, comparable. So comparable is a predefined interface in java.lang package. Okay, and then we don't have to explicitly import it. And then rule number 1 done. The class is implementing the comparable interface. Rule number 2, I specify the generics type of which objects am I going to compare. In this particular scenario, I am going to compare car object. So I'll tell it as implements comparable, and I'm going to compare the car objects with the help of generics type. But why is it giving an error, guys? It's common sense, no? Sir, when a class is implementing an interface, you have to override the abstract method. So therefore, the abstract method present in the comparable interface is public, okay, is the return access specifier, int is the return type, compare to is the method name, okay, open curly braces close, and this is an overridden method here. Okay, I'll write as annotation override because the class is implementing the comparable interface and we are overriding the compare to method here. Public is the return access specifier, int is the return type, compare to. And what type of objects am I comparing? I am accepting car object. So I'll write it as car C here. But now here I have to write the business logic for comparison over here. So I will tell return. Why return? Because it is accepting an int value. Okay, the return type is int. So I will tell this dot cost, meaning the current object's cost minus C is nothing but the already existing object's cost here. So as soon as I write this entire logic over here, and when I run my program over here, look at the output here. See, can you see here? The car objects are sorted into ascending order over here. Successfully, I'm getting the output here. The car objects are sorted on ascending order. Sir, how did we get this, sir? Okay, I will tell you the theoretical way now. Okay, now. So just concentrate over here for another 10 minutes over here. Okay, another 10 minutes I want you all to concentrate. Okay, see, first of all, I created 3 objects of car. Do you all agree with the process here? Correct? I created how many objects here? 3 objects of car here. Okay, so let me just define all the 3 objects over here. Okay, this is 111. C1 is pointing to that object. 222. C2 is pointing to that object. 333 and C3 is pointing to that object. And each and every object will have something called as cost that will get initialized to some respective value. Okay, the cost will get initialized here. Here it is 200, here it is 300, and here it is 100 here. So in simple terms, look at my program here. Three car objects got created, C1, C2, C3, wherein the cost got initialized to 200, 300, 100 here. The same thing I've done it in a pictorial manner. Clear? Now here, I created a tree set object. When I tell tree set object, it is going to sort. Okay, it is going to sort here. Clear? Now here, the first step over here, the first step, step number one, I will tell T dot add of. I am adding which object? C1. I am adding the first object. C1 means 111. When you add the first object over here, it will get stored as it is. Okay, just assume here C1 will get stored. Okay, and what is the address of C1? It's 111. And what is the cost over here? The cost is 200. Okay, and the cost is 200. C1, the address is 111 and the cost in the C1 object is 200. Clear? Now here, the second step, T dot add of. I am adding C2, the second object of car here. So in simple terms here, whenever you add an object into tree set, which method will get called? Compare to method will get called here. But now, since I'm adding the car objects here, it will go in search of the compare to method present in the car or class here. Plus means public, int is the return type, compare to is the method name. Okay, compare to method is the method name. It is accepting an argument C, and over here I am returning. Okay, I am returning one specific logic here. That logic is nothing but this dot cost minus C dot cost here. This is the logic here. Okay, now first of all, what is happening internally? T dot add of C2 means C2 is getting added. Dot compare to, okay, compare to already existing object, that is C1 here. Got the clarity? See here, C2 is going to get added. C2 dot compare to already existing object is C1. So I am passing C1 to C here. So C2 can be referred as 222, and this is nothing but the current object which is going to get inserted. Dot compare to C1. C1 is generally called as 111, and that 111 only is getting stored into C here because I am calling the compare to method and passing C1. C1 means 111, that is getting stored into C here. That can be referred as C here. And what am I returning over here? Returning what? This dot cost. What is this dot cost? This means 222. 22 means C2. What is C2 dot cost here? It's 300. So 300 minus C dot cost. C means 111. 111 means C1. What is C1 dot cost? It is 200. So 300 minus 200 is 100 here. It's a positive value. If it's a positive value, it moves towards the right side. So from here, the control goes towards the right side here. C2, the address is 222, and then the cost is 300. That will get stored here because I am calling the compare to method. And then for the third step, okay, for the third step, what is happening? For the third step, I will tell T dot add of. Okay, I am adding C3. I am adding the third car object. Okay, C3 means 333. So now internally, what is happening? When you add an object into tree set, which method will get called? Compare to. So which is the object going to get inserted? C3. C3 is going to get inserted. C3 dot compare to. And which is the already existing object? C1 or C2? I have to always point to the root node. That is nothing but C1. So therefore, C3 can be referred as 333, and that can also be referred as this here because this is the object going to get inserted. And C1 can be referred as 111, and that object only I am passing it to the compare to method. See, I am passing C1. That object will get stored into C here. And now when I tell this dot cost, this means 333. 333 means C3. What is the cost in C3? The cost in C3 is 100. Okay. So therefore 100 minus C. C means 111, 111 means C1. What is C1 dot cost? It is 200. 100 minus 200 is minus 100. Therefore, it's a negative value. It's lesser than. It's a negative value. So it goes to the LHS here. So now what happens over here? Finally, one more object will get stored over here. That is C3 and the address is 333 and the cost is 100. And what is the traversing order? Left node, parent node, right node. So left node is 100, parent node is 200, and the right node is 300. Since we have overridden the toString method, I will get the actual content. If I do not override the toString method, I will actually get the fully qualified class name. See, I get the addresses of all the three objects. But if I override the toString method here, I will actually get the content here. Okay, so this is how we are supposed to compare the user defined objects and sort them based on one particular order here. This is what we are supposed to understand in entire session here. Clear? It's a very simple program here which you are supposed to understand here. Okay, so over here what is happening? Car is a class. It is having a variable here and we are initializing that variable with the help of a constructor. And I have overridden the toString method because I want the actual content to be displayed, not the address. Clear? So now here I create three objects of car. I create a tree set and I'm going to add all the three objects of car. But the specification of tree set is to sort. Whenever we add an object into tree set, compare to method will get called. But since we are adding car objects here, it goes in search of compare to method in the car class. That's the reason the car implements an interface called as comparable and the object type, a generic type is car. And I will override the compare to method in such a way, I will write the business logic for comparison over there. So once we add an object over here, okay, therefore, we are supposed to do here. And then we will traverse it with the help of for loop here. This is all about the entire process of understanding how do we compare here. And now I will be doing 2-3 examples here, not a single example. In the first example, you just need to understand at least 30 to 40%. Okay, not completely. If you just understand 30 to 40%, when I give other programs here, you will easily understand the process. Clear? Now I will go back to my example, one more example, so that we can try to do it in a beautiful manner here. Okay, so now, okay, great. So now I'll explain it with one more program now. Okay, Control N. Okay, Control N. So now over here, I will create an object of student here. Okay, I'll create a class called as student. Okay, so here we created a class called as student. Now here, every student will have a couple of properties. Each and every student will have ID. Every student will have name here. I hope everyone understood this, correct? We just have a student class and we have two properties called as ID and name here. Now here in student class over here, okay, student, I will initialize the members here. So I will tell int ID, comma, string name here. Okay. So within the constructor, what am I supposed to do? This dot ID equals to ID and this dot name equals to name here. Clear? So what happened here? We have a class called as student. We had two variables and we are initializing those two variables with the help of a constructor. And now I will also override the toString method. Public string is the return type, toString is the method name. Open parenthesis close, open curly braces close. And I will tell return ID plus give a space plus name. So I'm just trying to print this entire process. Okay. And this is an overridden method. Okay. So this is all about the entire process. I have a student class, two variables, initializing it with the help of a constructor. And I have overridden the toString method because I do not want the fully qualified class name. Rather, I want some beautiful statement to be printed. Okay. So that's the reason I have overridden. Now I will create one more class and the class name is sort student. Okay. What is the class name? The class name is sort student. So now over here, sort student is done here. Now in this specific program here, what am I going to do here? I will have my main method wherein the execution will always begin from, and I will create three objects of student here. Student S1 equals to new student of ID. You can pass anything 103, and the name I'll pass it as B here. You can give any names, guys. Sorting will happen in a beautiful way. But just since I just want to explain it, so that's the reason I'm taking it as ABC here. So three objects. This is 2, 1 here, and this is 2 here. And here I'll write it as C, and I'll write it as A here. So I created three student objects here, and then I will create an object of tree set. Tree set T equals to new tree set of. Okay, I create an object of tree set. Now I have to import the tree set from the util package, and I will add all the three objects into the tree set here. S1 T dot add of S2. Okay, T dot add of S3. Okay, so now my tree set has to allow only student objects. So I'll write it as student over here, and optionally at the constructor side also you can specify. Even if you don't specify, it works fine. I have told you, right, several times. But if you want, you can specify here. Okay, and I want to traverse it with the help of for each loop. Okay, and you will traverse it with the help of what? For each loop here. Okay, now here, what type of objects are we going to traverse? Student object. Okay, student obj means it is going to get one object from the tree set here. Sys out, I will write it as obj. Now can you tell me what will be the output of my entire program? What will be the output of my entire program? It's just a random guess here. Now at least you should at least be able to visualize here what happened here. Okay, the first program. Now tell me what will happen now. What will be the output, guys? Think and tell. No, think and tell. I'll give you time. Think over it. Apply common sense. What will be the output? Okay. See here. It's very simple. Okay. When I execute it over here, I will get an exception called as, not an error. We will get an exception called as class cast exception here. I will get an exception. What is that exception? Class cast exception. Sir, why, sir? Why will I get class cast exception, sir? It's very simple. See here. The job of tree set is to sort. Correct? The job of tree set is to sort. Correct? So when I add an object into tree set, compare to method will get called. Clear? Compare to method will get called. If I was adding only integer objects, the compare to method in the integer class will get executed. If I was adding double objects, the compare to method in the double class will get executed. If I'm adding string objects, compare to method in the string class. If I was adding character objects, compare to method in the character class. But now in this particular example, I am adding student objects. So now internally it goes in search of compare to method in the student class. It goes in search of what? Compare to method in the student class. Is there the compare to method here wherein the logic for sorting is written? No, there is no compare to method. So he will tell, hey, dabba fellow, the comparable objects, I mean the student objects are not comparable as of now. See, numbers are comparable, strings are comparable. They have written the logic here. But even students are comparable. I need to tell, no, should I compare based on the ID or should I compare based on the name here? I have to explicitly tell on which particular criteria you need to compare and sort them. So therefore here we have to make the student object as comparable in nature. What are we supposed to do? We have to make sure the student objects as comparable in nature. So how will I make it as comparable in nature, sir? Rule number 1. The student class has to implement, okay, has to implement the comparable interface. Very good. Okay, rule number 1 done. So it implements the comparable interface. Since comparable is present in java.lang package, we need not import it explicitly. Rule number 2. Rule number 2 here is, since comparable is applicable for everyone, even car class can use comparable, student class can use, employee class, monkey class, donkey class, every objects can be comparable in nature. But now I have to specify the generics type and tell, hey, as of now, which object are you trying to compare? Am I comparing student objects? Yes. So I will write it as student here. I will tell it here. As of now, I am going to compare only student objects, not employee, not car, not bus, not pen, no other objects. So student implements comparable interface and I am explicitly telling it as I am going to compare student objects. If I don't write it here, it will assume it's object. It can take any types of objects here. It can compare. So that's the reason I write generic type and I'll be precise here. Oh, as of now, I'm going to compare student objects only. After that, so when a class is implementing an interface, what are we supposed to do? Override which method? Compare to. Okay, not compare method. The method name is compare to. Public is the access specifier where everyone can access it. It returns an integer value plus one, I mean positive, negative, zero, and the method name is compare to. Okay, compare to. So after that, I have to write. So as of now, whose object am I comparing? Student. So it will accept an object type, student type reference here. Clear? So it's an overridden method. Okay, it's an overridden method here. Okay. Now here I have to write the business logic for comparison. How do you, point to the current object? This here, the current object who is going to get inserted dot the current object's ID minus the already existing object's ID. That is only I'm passing it to the compared to dot ID here. Clear? So I have written the business logic of comparison. So now when I execute the program here, if you could closely see here, it is sorting based on the ID. See, 101, 102, 103. It is sorting based on the ID here. Clear? Now here, I don't want to sort based on the ID, sir. I don't want to sort based on the ID. Now I want to compare based on the name here. So how will I do it on name here? How will I do it on name? Okay, sir. Public is the access specifier, sir. Int is the return type, sir. Compare to is the method name, sir. And it is accepting a student argument s, sir. Okay, so now it has to return something. So how will I write it down over here? Annotation override. Return, I will tell this dot name, okay, minus, I'll write it s dot name over here. But it gives a huge error. Why does it give a huge error over here? It's common sense. If I just hover on it here, the operator minus is undefined for in the string class. It simply means if it was numbers here, you will easily call here. If it was numbers, you will easily subtract it. But if it's a string, how will you subtract? Can I tell monkey minus donkey? Can I tell that way? Can I tell guldu minus dinga here? How will it compare, guys? I cannot use minus operator over here. So that's the reason here. What I'll do, okay? There is compare to method in the string class, correct? So I will tell dot compare to, okay, s dot name over here. So what am I doing here? I am calling the compare to method. See, this dot name means it's a string. String dot compare to another string. I am calling the compare to method present in the string class, wherein the logic for comparing, converting the string into its respective ASCII value and to sort it, it's written in the compare to method of the string class. If you want to cross check, press Control on your keyboard, hover on the method, click on the method. So where is it taking me to? See here, it's taking me to the compare to method in the string class. See string dot class here. So the logic for converting the string into its respective ASCII value and then trying to compare it, everything is written over here. Okay. So that way, we are supposed to call that method. Now when I try to execute the program over here, see here what is the output I get. See, now the sorting is happened based on the names here, A, B, C. You can give any name here. Okay, you can give any name, it will sort. But let us try to see the theoretical explanation for it. How is the sorting happening for it here? Yes, absolutely. So let me go to the, I open a new sheet. Okay. So how many objects got created? Three student objects I'm creating, guys. Okay, three student objects I'm creating. So let me just do it for you here. Okay, three student object. This is student one object. This is student two object. And this is student three object. Three student objects are getting created. Let me do it. 111, S1 is pointing here. 222 and S2 is pointing here. 333 and S3 is pointing here. Okay. And then here I have every object will have two variables, ID and then name here. Okay. And ID and then the name here. Every object. See, there are three student objects, three students here, and every student will have ID and every student will have name here. Okay. So now ID, the name over here is B, this is C, and A here. And what is the IDs I have passed here? Let me just cross check. 3 to 1 2. Okay. 103, 101 and 102. 312 BCA. Yeah, okay, same thing. Okay. Three student objects got created. ID name, ID name, ID name got stored respectively. So now internally, see here. First step, T dot add of. Okay, T dot add of. I am adding the first object. Okay, I'm adding the first object. So now here, the first object will get stored as it is. S1 will get stored as it is. Okay, because this is the first object to be get inserted. The second part over here is I will tell, okay, T dot add of. Okay, T dot add of. What am I adding? S2. So S2 means S2 object is getting added. So S2 dot, it is internally calling which method? Compare to method. Compare to S1 here. Okay. So S2 can also be referred as 222, correct? And S1 can also be referred as 111. And then S2 can be referred as this here. Why? Because I'm adding that object into the tree set here. And this is already existing object. So that I am calling the compare to method. No, see, I'm calling the compare to method and passing that S1 to S here. So that can be also referred as S over here. Clear? So now what am I returning over here? I am telling this dot name dot compare to, okay, compare to s dot name over here. That is what is the logic here I'm returning. So when I tell this dot name, this means 222, 222 means h2. What is h2 dot name here? It's c. Okay, now it is c dot compare to s dot name. S means 111, 111 means s1. What is s1 dot name? It is b here. It is getting compared with b here. So now it's a string. It's a string. The logic for converting the string into its respective ASCII value and subtract, it's written in the string class. So what is the ASCII value of 6? C here, it's 67 minus, okay, B here is 66. 67 is greater than 66. 67 minus 66, it's always a positive value plus 1. If it is positive value, it goes to the RHS. So now S2 object will get stored into the RHS here. Clear? Understood? Similarly, what is the third step over here? The third step here is, okay, let me just write it down over here. T dot add of. I am adding the S3 object. Okay. So now S3 internally, when you add an object into tree set, compare to method will get called. S3 dot compare to and the already existing object. So already existing object meaning which is the root node here? The root node is S1. So it will always point to S1 here. So S3 can be referred as 333, the object address, and S1 can be referred as 111. S3, I mean S333 can be referred as this here because that is the object going to get inserted, the current object. Then S1 can be referred as S because I am calling the compare to method and I'm passing S1. That S1, see, I'm calling the compare to method, I'm passing S1, that is stored into S here. Okay, that is stored into this S here. That is called as S. And what am I returning over here? I am returning this dot name dot compare to, okay, compare to S dot name. So what is the output here? This means 333, 333 means S3. S3 name is A dot compare to. Okay. Then what is it? S means 111. 111 means S1. So what is S1 dot name? It is B here. So therefore it's getting compared with B. So A means 65 is lesser than 66. Correct? B is 66. 65 minus 66. It's always a negative value. So it moves towards the left side. So what happens over here? The control comes over here and S3 will get stored here. So what is the name in S3? It is A. What is the name in S2? It is C. And what is the name in S1? It's B. So what is the sorted order here? A, B, C. Left node, parent node, right node. So it is ordered, sorted in this particular order. So that's what we are supposed to understand. See, when you add an object into tree set here, since it is student object, I am calling the compare to method. So now in compare to, I have to compare the strings. Therefore, this dot name is a string dot compare to s dot name, meaning I am calling the compare to method of the string class again. So I call the compare to method in the student class. That student class compare to is calling the string class compare to. So that way we are supposed to understand the specific logic here. That's how we are supposed to analyze and get the program done here. Clear everyone over here? So student class is having two variables and I'm initializing all the variables with the help of a constructor. And I have overridden the toString because I want the data, whichever data I have passed, I want the data here. Now here, why have I overridden the compare to method? Simple. I have to compare the student objects based on one particular criteria and try to sort them later. So that's the reason I will tell implements comparable and explicitly tell what type of objects I'm comparing. It's student. And I am trying to write the business logic of comparison over here. So then three student objects got created. When we add the objects into tree set, the logic, it calls the compare to method and I have written the business logic for comparison and then it will get sorted here. So this is what we are supposed to understand. So now when I execute the program here, will I get the output here? See, it's sorting based on the name here. Now you can give any name here, okay? You can give it as Alex over here and you can get it as Brian over here and here you can give it as Craig over here. Okay. So now when I execute it over here, you will get the output here. See, you will get this data here. Okay. So you will get this entire data here. Okay. So this is what, see, it's sorting based on the names here. Alex, Brian and Craig here. So that way it's a very, very simple process that we need to understand here. Clear? So this is all about it, guys. Okay, so you just have to understand how do we implement the comparable interface. Okay, so in simple terms, if I go back to the theoretical part here, what is comparable? It's a predefined interface in java.lang package introduced from JDK 1.2. Okay, it also has an abstract method called as compare to, which returns positive, negative, 0, greater than, +1, minus 1, lesser than, and 0 if it is same objects. Okay, and why do we use comparable? To compare the objects and sort them, and that is used for default sorting. And I have written the rules for implementing the comparable interface. So you have to just understand the rules here and try to implement it practically over here. Clear? So anyone having any questions as of now? I'll be doing one more program for you all here. Okay. So Control N. I will create a class called as employee. Okay. I'll create a class called as employee. Done. So in employee class over here, okay, let me have, many data here. Okay, so I'll just write it as int. I'll take it as ID only. Okay, string. I will take it as name only. Okay, and I'll take it as double salary here. Okay, I'll take it as double salary over here. Okay, this is all about the entire data. So each and every employee will have three properties: ID, name, salary. Okay, and alt shift yes. I'll generate a constructor with fields wherein which I have told here. Okay, so you have to initialize the initialize those data members with the help of a constructor. And I will also, have the toString method over here. So I will have the toString method in a beautiful manner here. I have overridden the toString method also. Okay. So what will be the output like? You will get to know it later. Okay. We are just concatenating the data here. Okay. If you trace down, you will understand. So now over here, Control N, I will create one more class called as test employee. Okay. And I'll also have my main method. Okay. And now over here, I will have three objects here. See, first directly tree set t equals to new tree set of. Okay, I am creating an object of tree set and I have to import it. So now first of all, I will create an employee object. See, employee e1 equals to new employee of, and the ID is 2, and the name, I'll pass the name as his name is John here. Okay, salary is imagine is 45.67. Clear? So now similarly, I will create one more object. This is employee E2 here, and his ID is 1. Okay, and his name is Jack. Okay, and his salary is 62.45. Okay, and this is all about it. So I created two objects, and I am adding those two objects into my collection. E1 d dot add of e2. But now I want to allow only employee objects into my collection. So I'll write it as employee over here as well as employee over here. Okay, I'll just add the employee objects. Clear? Now we can add the objects directly as well. New employee of ID is 4. The name, we'll write it as Tom, and the salary is 12.56 here. So that way also we can add the employee object directly, or you can, create an object, store the address into E1 and pass the object reference. So anything is fine here. It's not that we have to always follow this particular structure here, but you can follow whichever structure you want. Here I'll write it as Jerry over here, and the salary is, he's getting 99.67 here. 4 1. Okay, great. So now I want to traverse it with the help of for each loop. So here, I am having employee objects into my collection, correct? So I'll tell employee emp colon from the tree set t, and I am trying to print the object reference. Now quickly tell me what will be the output of my entire program. See, I created employee objects, I created tree set, and I'm adding all those employee objects into tree set and trying to traverse them. What will be the output now, guys? What will be the output now? Now if you tell wrong answers, now I'm going to kill you seriously. Okay, so just think and tell me what will be the output here. Yeah, I'm expecting answers, guys. Okay, so just let me know here. Okay, what will be the output here? What will be the output? Very simple here. Okay, we would get one exception over here. Why, sir? Why, sir, exception? See, when I execute it over here, I will get an exception called as class cast exception. See, I'll get an exception called as what? Class cast exception. Clear? Why did we get class cast exception over here? The only reason being over here, okay, sir, whenever you add an object into tree set, compare to method will get called. Now we are adding employee objects. So the compiler will go in search of compare to method in the employee class. Do we have compare to method in the employee class? No. So that's the reason we are getting an exception. So what are we supposed to do? Sir, make the employee class as comparable in nature, sir. Okay. How will I do it here? Implements. So I will tell, just a moment, something happened. Yeah, 2 minutes, guys. Yeah, perfect. So implements comparable. Rule 1. Okay, sir. Implements comparable. Okay. And what type of objects am I comparing? Sir, it is asking the element type. Type A, what objects are you going to compare? I want to compare employee objects. Appa. Okay, now that's it. So I have to override the abstract method called as compare to. See, it's already giving the structure here. It's already giving the structure. So here I'll write it as employee E here. So here, what is the logic of comparison, guys? Based on the ID. Can you tell me if I want to compare based on the ID, what will I do now? Can you just tell me here? Return, what am I supposed to do if I want to compare based on the ID here? Current object. How will I point to the current object? This dot ID, it's a number, minus, I can write it as E dot ID here. So the current object's ID minus the already existing object's ID. So now when I execute the program over here, can you see the beautiful output what we get here? Because the toString method has been overridden and I'll get the output here. See, it's sorted based on the name ID here. 1, 2, 3, 4. It's sorted based on what? Based on the ID here. Clear? Similarly, if I don't want to compare based on the ID here, what am I supposed to do here? If I don't want to compare based on the ID, I want to compare based on the name. Imagine. So how will I compare based on the name here? So this is annotation override. So what will be the logic over here, guys? Can you tell me the return? What am I supposed to return? This dot name. Should I use minus here? Minus e dot name here? It's giving an error here, right? So what am I supposed to do over here? What am I supposed to do here over here, guys? I have to call the compare to method internally of the string class. Dot compare to method of the string class here. Very good. So now when I execute the program here, the sorting will happen based on the names here. See, Jerry, Tom, over here, okay? Jerry, Tom, Jack. See, this is lowercase j. That's the reason it's sorting based on the ASCII value. If I just give it as, okay, here I'll just give it as Aaron, okay? So now, when I just execute the program here, see, look at the output. A, J, E, J, O, and then Tom. A, J, J. If it is same, it sorts on the based on the second ASCII. So, I mean, some or the other way, it's trying to sort here. So the sorting is happening based on the ASCII values here. Clear? So that way, now if I want to sort based on the salaries here, how will I do it here if I want to sort based on the salaries? It's simple. So E dot, I have to just write it as this dot salary minus, okay, E dot salary, because it's numbers. But still I get an error here. Can you tell me the reason why it gives an error here? Sir, this dot salary means, imagine it is 1.2. Okay, imagine it is 2.4 appa, minus 1.2. If I tell, the 2.4 minus 1.2, I will always get the output as 1.2 over here. Correct. So therefore here, okay, therefore here, I cannot, I cannot change the return type of int here, because the compared to is fixed. So it is always public, it is always return type is int, and it is compared to. I cannot change the return type and all over here. Okay, it's always the return type will be int only, because it's a predefined method. I cannot change while overriding. What are the rules here? We need to follow those rules, right? So what am I supposed to do? It's telling, say, type mismatch cannot convert double to int here. So I have to add a cast here. So when I tell cast here, so this dot salary minus E dot salary will return a decimal value. So the integer value of that respective decimal value I am trying to sort here. So when I execute the program over here, see, is it sorting based on the salary 12, 45, 62, 99? Yes. But what if I have the decimal value same here? If I have 67 only, all the objects will have 67 only. Now when I execute it, see here what happens over here. Okay, it's sorting over here, right? But based on one particular order. Okay, it's randomly sorting over here. Okay, so that's the reason. And one more thing, what if I have the same things here? 12, I'll have it as 12.34. Okay, 12.89. So I'm having the non-decimal value same, but the decimal value there is a change here. If I try to sort it over here, see, these objects are not at all inserted over here. Got the clarity here? So therefore, if I just typecast it over here, it will compare only the non-decimal values here. The decimal values are ignored here. See, this dot salary minus E dot salary is 2.4 minus 1.2 is 1 point. Okay, wait, we'll take this one. 1.1 is 1.3. So when I tell integer value, it will compare based on the non-decimal value. I have to compare based on the non-decimal value only. So how to do it here? You have to explore it today. I know the solution for it. Okay, I'll be doing it tomorrow here. But you have to just follow the exact data over here. Okay, got the clarity over here? So this is what you're supposed to understand. When I just typecast it this way, only the non-decimal numeric values will be compared, not the decimal numeric values. So if I want to compare, I have to find out one logic here. So what is that logic here? You think about it. Clear? So now when I execute it over here, I am getting this respective output here. Okay. So how to compare based on the decimal values here? You think about it and let me know here. Okay. So that it becomes easy for understanding the tomorrow's session here. So this is all about the entire process. Okay. Any questions, guys, as of now here? Any questions as of now here? Any questions as of now? Okay, great. So there is one question here, sir. How do we do it in descending order, sir? Okay, good question. Okay, see here. Imagine I want to compare based on the ID. See, I'm writing the compare to method based on the ID. See, this dot ID minus E dot ID will always give it an ascending order. Okay, the current object. See, the ID is 1, 2, 3, 4. It's sorted in ascending order here. But if I want it in descending order over here, I have to just swap it over here. So I will tell return E dot ID minus this dot ID here. I have to just, reverse of it. So once I just reverse of it over here, I will get it in descending order. See, I'll get it as 4, 3, 2, 1. So if I do it as current object minus already existing object, see, current object minus already existing object, it is always ascending order. The reverse of it, ulta of it, the or already existing object minus current object, this will give me in descending order. So that way we are just supposed to analyze the content here. We can do it for name also. Okay, it's not that we can do it only for this one here. We can do it for name also. Okay, how can we do it for name, sir? It's simple. Okay, what will you do for name here? You will just change it to e dot name dot compare to, you have to just write it as this dot name. So once you do this here, the sorting will happen based on the descending order. See, Tom, John, Jerry, Aaron here. So that way the sorting is happening based on the descending order. So this is all about the entire process, guys. Okay, so you just need to understand what is comparable in a beautiful manner. Okay, now I want to complete comparator. Okay, so comparator is a very important topic, and the prerequisite is comparable. So since we did comparable here, go through the entire video once again here, the programs over here. Try to develop your own programs. I took student, I took employee, I took car. You take your own objects here. Take shoe objects. Okay, sort based on the cost, sort based on the size, or whatever it is. Take student, take whatever laptop. Take laptop objects. Sort based on the brand, sort based on the cost, sort based on the RAM size. So you take your own real-time examples and try to do it here. Clear? So this is what we are supposed to do here. Okay.